This video is about how you handle missing data in a data set, and it's an exercise that shows you how to clean up a data set. The most typical strategies for data cleanup includes a set of deletion options, which is 1, 2, and 3, and a set of imputation options, which is options 4, 5, 6, and 7. For this exercise, we will be focusing primarily on the imputation options 4 through 7. The data set for the exercise is this set of data about chocolate, and we are using the flavor study data. We basically have two tasks. The first thing is that we have to identify the missing data, and then second of all, we'll have to control for problematic data points inserted. So look at and locate empty data, and then locate data that is not correct. With a big data set like this, and let's go down to the bottom, see how many rows of data we have. We have 664 respondents in this data sheet. So with a data set like this, it is possible to identify the missing data and the erroneous data manually. However, the exercise here is more about how do you do that. Let's say if you had 1 million lines. So you will have to find some type of automatic way to do it. So let's test the first column and look at the first one. Milk. How would we figure out where there are missing data here? A simple strategy is to use the data sort function. The data sort function enables us to sort them in ascending or descending order. So let's try to do that for this data sheet. So first of all, we select the data sheet we want to sort. And in this case, I'm using all the numerical data that we have, and I am including the title on the top, because once you start sorting, so sort, you can list the sorting with headers. So in this case, I want to include the headers, because when I include headers, I can see the headers in this sort by list. So let's say I want to sort by milk. In this case, let's say we sort from smallest to largest, and then we sort everything. Right? So here we've now sorted after milk. Let's go down to the bottom of the data sheet. And now we can see that there are 2 missing. So in order to start, let's mark these guys out. We need to put something in here. Now, in order to figure out whether or not we have problematic data, then we'll have to test all these numbers to see if there's something that is outside the acceptable range. So in this case, when we listed them like that, we can see they start from 2, they go to 5, and at the end we have 2 empty. So it doesn't seem to be any erroneous data here. However, if we wanted to do an automatic a test of this, we'll have to put in a formula that identifies whether or not there would be answers that are outside the range of 1 through 5. So what we will probably do, or what we could do here, is to put in a formula that identifies how many observations would be smaller than 1 and larger than 5, for instance. So how do you do that? Well, one way to do it, for instance, would be to make a couple of rules. And you see here I've set up rules that says smaller than 1 and larger than 5. And in order to do a formula that counts how many is smaller than 1, larger than 5,
we have a Excel function, and to speed up how you do this, I put in the formulas here. So you see up here in the top, you use the count if function from B4 to B666, and this is the criteria, so it is in apostrophes. This is smaller than 1. So in this case, there's nothing smaller than 1. You can use the same formula for larger than 5, and you see again there is none that's larger than 5. You can actually also have a formula that counts how many are empty. In this case, we use a function called count blank, and you see I've inserted the range here. Now, in order to handle these missing cells, we'll have to decide, all right, so what do we do with these cells? One strategy we might want to use is to insert the central tendency. So central tendency could either be 4.65 or 5. In this case, I put in 5, it's the median. Would this be better than the mean? Well, that's also up for discussion. I do think in this case, because we have respondents giving a specific number from 1 through 5, putting in 4.65, for instance, does not represent a real answer. So in this case, I would probably suggest to use the median. Now, because we have made these formula, or this little analysis for one column, we could actually do this analysis for all the rest of the columns. We'll just copy these formulas into the other cells that we have, which is pretty easy to do. But before we start copying these guys and copying into these cells, let's check if the formulas are ready to be copied. So what's going to happen with this one is that when we copy this one, bring it one to the right, because we have $signs in front of both ones, it will be exactly the same on this one. However, this column is column C, and you see this copied as B, which means that the formula up here is not correct. We have $signs in front of B, and we do not want to have those $signs in front of B. So we go back to this one. We correct the $signs, take them away again, so we just have it for the numbers, so the rows. Let's see, I'll cut them out. There we go, that one, return. So now it should be correct. So let's move it out again, test it. Now it's C4 to C66. That's exactly what we want to have. So that's the right type of formula. So let's check the other formulas. We have the same issue here. Get them out of the way. And let's get the $signs out here and here. And this one, we don't have the $signs in them for the rows. So let's put it in for the rows just to be sure. All right, so here we go. All right, so let's do the analysis for the rest of the columns. Just drag it out. And there we go. So now we have analysis. We then have an overview of what's the problematic things here. Which gives us, of course, a quick overview of what we have and what we can do with stuff. Now, because we have this analysis, we don't see where the empty one is. So we have in this one, and we have to go through it manually if we want to find that specific one. Now, and then we'll have to do that for every single row. There's also another way you can get around this. So the other way to do this is to create a data sheet that's cleaned up. So let's go up to the top and let's create the same data sheet but just with clean data. So let me copy first of all the headlines. We'll put it over here. And I will adjust the width of these. I can do that by just marking everything out and moving them a little bit. I can then mark these ones out. and I click on them, and then they become a little smaller. All right, so now I have copied row 1, 2, and 3, and then so the cleanup version then has to input what do we need to put in here. In order to do so, we can use an if formula. So we can specify what goes into this cell, depending on a number of different criteria. So let's put in an if, and you can follow along up here. So if this, and we're talking just about this cell. Now, these are respondents. So this cell we actually do not want to change because we have the same respondent. So we just take the respondent out here, and this returns the same respondent as in that column. So the second column, that's where we start getting the data. So for this column about milk, we know that we like to have this one, this milk, but only if it's within the range we're expecting, right? So if B4 is equal to or larger than 1, and B4 equal to or less than 5. So if it's within the range we want, then it has to return, and then it's B4. Now, if it is not within that range, which we know that 2 are not, then input instead the strategy, which is the mean. So let's go down. Let's get the mean. Down here. Sorry, the median. Median, you see it came up here to the formula. So we close the cell. Right? So now we have a formula here that says if it's in the acceptable range, insert the original data. If it's not inside that range, insert the median from B672. So let's close that one out. Oh, so there's something wrong with this. I probably input some space in there. I did. So I had some spaces in the formula, and it actually suggests how to clean it up to take out the spaces, and we say yes, and there we have it. So now we have a formula that within 1 through 5 puts in what we have, and if it's not that, it inputs the median. So now I can start creating a data sheet with the cleaned up data, right? We have this one for that. We just copy them all the way down. So we have the same respondents. And then we can do this for all the columns of data that's relevant, which is probably age. Sex is binary, is either 1 or 2. So let's just not do it for these ones yet. Let's just go with the flavors. That's the ones we've been looking at. So we'll copy these ones out to cover all the flavors. And we'll copy them all the way down to whatever, 600 something, 666, I think, something like that. There we go. So all of a sudden now we have a data sheet. That should be correct. However, you can see that there's a lot of different zeros here, which means that there's a problem with the formula, right? So it didn't copy correctly. It did it for the first row, but it didn't do it for the second and third. So there's something wrong with the formula because it doesn't show up correctly. Let's see what the problem is. So the first of the ones that are 0 versus the one that's correct. So B is of course correct. If we go down to, sorry, did the wrong thing here. we go on to C, we can see that B5 is correct. However, B673 changed from B72 to B672 to 73. Here we go. So that's the problem, which means that this formula, because the median, or the mean is in the one specific row, that should not change. So we need a $sign here. All right, so now this one is correct. So that means that we can copy it to the rest of the sheet. So it goes there. And then we bring all of these guys down. Copy them down. 666. There we go. So now we do have a correct sheet. So now we're done with the actual calculation. We have a clean sheet. And in order to get this ready for analysis, what we typically do is then we copy the clean data and we put that in a specific worksheet. So in this case, I copy everything that's been cleaned up down to 666. There we go. That one. I do Control-C on my keyboard to copy everything. And then I created a new tab here. You see it's called Flavor Study Cleaned. The way you do that is press the plus here and then input the text. So it's really easy to add a worksheet. In this case, well, why don't we do that? I'll try one more time. So the sheet 2, I double click this, call it Clean Data. Return. Then I put in my cursor on A1, do Control-V to input. So now we got everything in there. Now you can see that the standard copy-paste function returns reference errors for all the different cells. And that is because we import it as it is. And the original had formulas here, but we do not want formulas, we want the values. So what we do is we change the way we paste it. Here we have, I'm right-clicking on this little box. Here we can do it, change we can pass it in different ways. I don't know if you can see it here behind my my video, but it's under pass values. You know what? Let me move this one up. So here you can see it. So past values. So this is the value, and there are 3 different options. We want all the formatting. So we normally choose value and source formatting. So we'll do that one. In that sense, we get all the values in here and we get all the formatting. So now it looks correct. So now we have a special tab or worksheet that has all the clean data. So there you have it. Let's briefly look at what we've done. Go back to the top. So we took a look at the data set of flavor study. We know we had poor data because there are things missing. We first of all looked at just doing a simple sort of this one, which is a very manual process. So instead of going through and sorting every one from low to high, what we did here was instead first make an analysis of the scope of the issues. And we did that in the last row. So we analyzed for what might tell us what problems we have: smaller than 1, larger than 5, and empty. And then after we've analyzed it, we went and made a clean data set. Directly by using an if formula that specifies, if it's correct between 1 and 5, we return the actual content of the cell. If it's not correct, we decided to input the median from B672. And then we did it for the rest of them. And then we took a copy of this, the whole sheet, and put it into a clean data worksheet. Now, one more thing we might want to consider is to understand how big a problem we actually had. And in order to do that analysis, let's go back to our list of analysis here. Let's see how big a problem do we have. So how many problems? So how many is dirty, or how many poor ones we have? Well, we've decided to look at cells that was smaller than 1, or larger than 5, or empty. And in this case, if we add all these 3 up, there are 2. So if we do this, we can then see how many issues do we actually have. Now, knowing it's 2 out of 600 and something, we might want to know how much it is in percent. So error percent. And in order to calculate that, let's first figure out how many respondents we had. So the original utility study, we've actually sorted it, so we can't really see, but we can actually use a little count function to tell us how many we have. So let's say equal count, and we'll count one that should be complete, which is the first row, respondents. And we'll count how many we have. So we have 663. Now, just to double check, we could also see if there are some of these ones that are empty. So let's say equal count. And here you can see blank. See if we can use the blank one. And we can do the same thing, just to double check that this is correct. Okay. Input the formula, and we see there is no blank, so we do have 663. So in terms of the error percentage, that would then be how many errors do we have divided by, in this case we'll just write it in, we'll do it like that. All right, so the error percent, and we'll change that to percentages so we can see it. Let's get some granularity to it. So 0.3% errors. All right. Let's see if we can do that for the rest of the rows. So what I will do here, just to make it simple, is that we know we have 663 respondents. That's going to be the same for all the different rows. So I'll change this to 663. And then I can take these ones out, and then I'll copy this formula to the rest of the rows, and then we can see what type of error percentage we have. Now again, once you do this, you can see it returns 0 for the rest of them. That should tell us that something wrong with the formula, and in this case there is. Because this one should be correct. Let's look at the next one. It goes to C, 673. 673, we had nothing in there, so we forgot to use this one. So in order to get it correct, we have to copy both of them at the same time. So that's the little error here. And once we do that, you now see that we have something we can work with. We have some good numbers, right? So here you can see the range of issues. Now, if you want to get a quick overview of this one, because you have many, you just basically let's mark up all the flavors. I think these ones were ages and things like that, so let's delete these guys. Don't need them here. But let's return to this one. So what you can do, just to get a quick overview, is to insert a formula. So what you do is insert, a graph, insert graph. So let's do a bar chart. There we go. let's just do a standard one. All right, so this chart actually shows us the problem area that we have for our data set. So we can see that the error percentage is highest for number 15, so the last row. So what row is that? So number 15, that's the one we're looking at, should be the last one in the row. So that's actually this one. So in terms of mint and answers for mint, that's where we have the biggest issues. But it's 1% or less. So basically the scope of issues we have is not very big. If we want to calculate the full scope of the whole data sheet, we'll have to aggregate the number of error percentages on average. So basically what we do here, just to make it simple, is that we take the average of all the different percentages here. So let's put in an average of these percentages. So we get an overall error percentage for the whole data sheet. So we can say that on average we have 0.6, 0.593 problematic data, which is not a lot in this data set. So that gives us a scope issue for the whole data set. So with this little overview, that is basically an example of how you can clean up a data set, how you can analyze it. To make it easy for you, I will save this document with the different formulas in it and the graph, and I will upload this under the lectures next to the original Marabou file. So in case you want to take a look at what I've done with the worksheet here, then you have access to it. So thanks for your attention. Hope it was fun to work with the datasheet, and now you have a full explanation of how this data would be cleaned up if we were doing this for the company at hand. Thanks for your attention, and see you in class.